Hello, Math 300, and this is Professor Gonzalez, and I would like to do some problems from, once again, I would like to do all the problems from section 13.4. I see some folks have completed it, some haven't done it, so I hope you're starting to look at 13.4 rather. I'm doing this video to clean up any misconceptions or areas that you're not sure how to do, so I'm going to do all the homework problems in this to help that out. The test is open, so that'll be open till May 11th. So you need to get on that. There's also a review test in Canvas for you with a key with answers. Anyhow, this section 13.4 is about the finance of buying a house, and it also it talks about the advantages of home ownership. And with the questions I chose, it's basically just covering finance of house. So I'll talk about some of the advantages right now. And the thing about, I think on the last section, I talked about the disadvantages of financing a car. And one of the biggies is that you're paying for the cost to use the monies, the finance charge. And on top of that, the commodity or the thing that you bought, a car, also loses value. So you're losing value in two ways. You have to pay for finance fees, and the product you have goes down and depreciates in value. So you got two losers. On the other hand, with a house, of course, you guys are all old enough, maybe not old, everybody's old enough to feel the pain of the Great Recession or the housing bubble that burst. But during that period, real estate was very painful. But historically, home ownership has a lot of advantages because unlike a car, most of the time, and if you hold it long enough, it does go up historically, shows that. But the value of a house goes up. So even though you have to borrow money and pay a big finance charge on it, the value of that goes up. Okay. It also provides shelter and stability, which a car really doesn't. So it provides shelter, stability. It's a product. It's a commodity or a product that goes up in value, even though you're having to pay, finance charges, and also the interest of your primary home. You're allowed to write that interest off when you're doing taxes. So you get a tax break, which you will not get a tax break on any other kind of loan, but you will for a home loan. Also, when you sign up for that 15 or 30-year mortgage, that is a case of forced savings in a way, right? Because if you don't pay that, you lose the house. So really makes you save money also, and kind of it's a real kind of foundation of building wealth and building your establishment. So there's a lot of advantages to home ownership. All right, let's talk about the finance of home ownership. The first question: find the monthly payment on a loan of $82,000 at 6.5% for 25 years. Use either a regular monthly payment formula or monthly payments to repay principal and interest on a $1,000 mortgage table. So as long as our table has the details that our mortgage has, we can use this table. Let me show you how to use it. And this mortgage table, like most of them that I've seen, it's going to be based on $1,000. So it tells you, well, we also kind of need to talk about it's called amortizing your loan. And what that does is it figures out your principal and interest each month with a monthly payment that stays the same for the full term. So your monthly payment would stay the same on a fixed mortgage, and so every month you pay the same for the next 15 or 30 years. And so that's nice. It's a predictable number. What does change is your amount of interest will be very high when you owe a lot of money, and as you pay that principal off, your interest goes down. and your principal payment goes up. So you've got these two pieces within that monthly payment that change as you pay off the mortgage, but your monthly payment stays the same. So those two balance each other. We'll look at that a little closer. But this particular chart is amortized based on $1,000, and so then all you have to do is take a look at, in this case, this is $82,000 loan, so all you'd have to do is multiply that by 82. But let's take a look. This table works in a pretty nice way. So what it's saying is find the monthly payment on a loan for $82,000 at 6.5%. So you have to identify the 6.5%, and it is on the table. And does it have the term of the mortgage? How many years we have to pay it off? And that's 25 years. And so the term is 25 years. And so this chart will show us, when you look at the intersection point, that it is, and this is in dollars. So basically they're saying if you had a $1,000 mortgage with that's 6.5% annual interest rate, and you had 25 years to pay it off, you'd have to pay $6.75 per month. But you don't have a $1,000 mortgage, you have an $82,000 mortgage. So all you have to do is take that figure we just figured out, which was and you don't want to round this, 6.75207. These are actually dollars. You want to multiply that by, you take a look at your loan amount, and essentially, since that already is figured for 1,000, you move the decimal over three places, and that's the number you want to multiply by 82. This is based on 1,000, and you want 82 of those thousands, so 82,000, right? So when you multiply those together, you end up getting, and of course you round to the nearest penny, you end up getting a monthly payment of $553.67. There's the answer. And I'm just going to continue to try to remind you, this payment includes your principal. So essentially what you find first is the interest. So it includes the interest, and then what's left over on that monthly payment goes to principal, which pays off your loan. At the very beginning of these loans, most of it is interest, and it's kind of hard to make that payment. You'll find that a lot of that, but we'll see in some payments coming up and some problems coming up, that a lot of that monthly payment at the beginning is just interest and not even helping you to pay down your mortgage much. It takes a while. All right, let's take a look at the next one. Next, problem number 2, find the monthly payment needed to amortize principal and interest for a fixed rate mortgage. Find the monthly payment needed. So we need to find this monthly payment, and that's what we pretty much just did on the last problem. The problem with this problem is that when I go to look this up, use a different color, I see 3.2%. There's no 3.2% on this chart. And there's another chart later on that goes down a little bit further, but still no 3.2%. So that really kind of stinks. So we can go, instead of using a chart, we kind of go old school, which is, actually it's not that old school. It's really good to know the formula. So we go ahead and use the formula. It's just old school compared to, somewhere a long time ago they started using charts, and then more recently, calculators and computers and stuff like that. Okay, so let's go old school for a moment here and check out that there is a formula R, which is the monthly payment to repay the loan that is amortized. Wow. And that formula is going to be principal, so the loan amount, times your interest rate divided by 12, all over 1 minus 12 divided by 12 plus that interest rate raised to the 12 times time. So in this particular problem, let's see. Oh, this particular problem we're supposed to be doing is right here. So let me take that formula and imagine it up here. And so that means that the principal amount, which is right here, let me use some color just to kind of maybe make it a little clearer. Your P, principal amount's right there, so that's 107,000. That was a little too bright. And then we have our interest rate divided by 12. Interest rate, remember that has to be changed to a decimal. 3.2% is 0.032 as a decimal, and it's divided by 12 according to the formula. And then down below in the denominator, it is 1 minus, in parentheses, 12 divided by 12 plus our interest rate written as a decimal, 0.032. And then that quotient is raised to the 12 times time. And we'll do time, I guess, in red, 25 years. And I guess I could have done that interest rate in blue. So the interest rate, once again, as, oops, that's erasing it. This interest rate as a decimal is 0.032, and it goes there. 0.032, and it goes there. All right, when you're simplifying this, let me see what kind of detail I want to show. Let's show some detail so you can kind of see some of my steps. You want to take the quotient of that first. So when you divide that, first of all, we still have the 107,000, and that's going to be multiplied by that quotient that I'll figure out right now, which is, and you really don't want to round much at all with this until the very end, 0.002, and then a repeating 6. So like as much as your calculator can handle. And then divide that by, and it might be a good idea right now to look at that exponent. What is 12 times 25? What is 12 times? I probably should be able to figure that out in my head. 12 times 25, but I won't, is 300. So that exponent is 300 right there. Okay. Okay, so before order of operations, before we subtract, we're going to have to divide and then take care of this parenthesis division. And before we divide, we're going to have to add that denominator because that because this bar goes all the way across, right? So that's got to be, you got to figure out what that is first. So you're going to add this. Let me just show a little bit of work over here. That's going to show 12 over. And then the denominator is 12 plus that decimal, so it's going to be 12.032, and that whole thing gets raised to the 300th power. So when we do that, let me just show a little more detail. We got 1, and everything in the parenthesis happened to be 0.99734. 4255, which also, before you did anything else, you had to raise it to the 300th power. And so then when you found the product up top, multiplying these two, you end up getting up top 285.333.262, repeating, or rather, ... showing that pattern continues. 0.5501923.515. And then hit the division button, and we get our R value is approximately 518.60 637. So we are going to round to the nearest penny, which would make that $518.61. Okay, so notice how I think you're going to appreciate the chart. With the chart, all I had to do was find its percentage, its annual interest rate as a percent, figure out the term in years, and look at that intersection point, which tells me how much I have to pay per month to pay off $1,000. And if I have 82,000, I just multiply by 82, and I've got it. Without that chart, look at all that work. Why didn't I use the chart? Because the chart didn't have 3.2%. So I've done other finance classes. I'm okay with making people, look up or use that formula and that kind of thing. But what I wasn't as crazy about was a problem coming up that had multiple steps dependent on that. I would have rather that been using a chart. And actually this one we can use a chart. There is one coming up where the term or the year in terms, the term in years rather, or the interest rate didn't show up on the chart. And in those cases, I'm going to show you that a simple amortization calculator, and I found one. There's so many of them out there, but I found a simple one, and I'll just share that with you, that you can use that. I'll let you use that calculator online, that you can do all that right there with by just pushing some buttons. But let's continue. Number 3, find the monthly payment needed to amortize principal and interest for the fixed rate mortgage. And if this does show up on my chart, I can just use the chart. Let's see. Well, in this particular problem, interest rate of 5.5 and term in years is 5. Do I have that on the chart? Yes, I do have 5 years. And what was that interest rate again? Interest rate needed was 5.5. 5.5, and that is on the chart. So luckily, this saves a lot of time. The number I need is 19.10116. And so that is amortizing the monthly payment, which would include principal and interest, for $1,000. And I just need to adjust to what I have. So once again, that number from the chart was 19.10116. That actually is dollars. And when I look at this over here, I need it for a loan amount of $206,750. Well, since that's already based on 1,000, we move this decimal point over and we use 206.75. And this will give us the monthly payment for a loan that is $206,750 at 5.5% for 5 years. How much do I need to pay per month to pay this back in 5 years? Well, that's going to be pretty aggressive because doing it in 5 years is pretty fast. You're going to have to come up with quite a bit of money. The positive side of paying something back fast is that you do not have as much of an finance or interest charge to the bank for borrowing the money because you're not borrowing it as long. Anyhow, when I multiply those two figures, I multiply them together, I get $3,949.16483. Of course, we round that to the nearest penny, and that would give us a monthly payment, which includes principal and interest, paying it back in 5 years at an interest rate of 5.5%, is going to be $3,949.16, which came from this figure, just rounding it. Okay, do you like that chart? I think you like that chart. The chart is your friend. Makes life a lot easier, much easier. Let's take a look at the next one. Complete the first month of the amortization schedule for a fixed rate mortgage. So when you start paying back your loan, you have many payments. And this particular one, you have to pay for 15 years each month. That's 15 times 12, which I believe is 180. 15 times 12 should be 180, yeah. So that's 180 payments. And this, they just want to see, show me what it looks like on the first payment, okay? And then you'd have 180 more of them. And once you got to the 180th payment, your loan is paid off. Now we want to know, so if we want to pay this loan off in 15 years, the bank is charging us 5.5% interest, and we're going to take a mortgage of $104,000. What do we have to charge? What do we have to pay per month? Well, this table is extremely helpful for that, coming up with a monthly payment as we saw before. And so let's go ahead and do that. Let's do that in blue, I think. So the particulars is 15 years. So here it is right here. Interest rate, 5.5%. Yay, we have that. So we will be able to use our quick little chart. And with that chart, we're going to write down the number to get our rate. Let's see. I think I'm going to do that up here. I'm going to use R for the value because remember in the formula, R is our monthly payment that's amortized. So monthly payment to pay back that loan in that situation. So the value that I just found out from this chart is 8.17. So remember that is dollars. It's 8.17083. Now that is based on $1,000, and I want this based on $104,000. So if that's based on 1,000, 1,000 is taken care of. I need to multiply it by 104, which is going to now adjust this. Instead of being for $1,000, it's going to be for $104,000. So my R value, once I make that adjustment and round to the nearest penny, it's going to be $849.77. That's what I have to pay back per month for 180 payments to complete this loan. Okay, so that's your monthly payment. That goes right here. $849.77. Now, that number doesn't change. That's your monthly payment from now until 180 monthly payments. That doesn't change, and that might seem what should change because this is going to go down as you go. And that's right, that does go down as you go. And so that's where you have this balancing thing that happens, where the very first payment you're paying lots of interest, and the very last payment you're paying very little interest, which means you're paying more towards your principal. So really the payment of the principal, the $104,000, accelerates later on in the life of the loan. It's very slow at the very beginning. Excuse me, if you stretch this out for 30 years, it's even slower for the first 15 years and then starts accelerating in terms of paying off the principal. The time horizon is the same, but the amount that pays off the principal goes up since your interest rate goes down. Not sure how clear that is yet. Hopefully an example coming up will help clarify just a little bit more. This is your first payment. So the question is, interest payment. How much are you paying on interest? What is that little thing that just popped up? Okay, so my screen is frozen. Is there something that I can do to unfreeze the screen? Maybe not. There it goes. Okay, good. So the question is, what is the interest payment? Well, the interest, remember, our interest formula is interest equals principal. And right now the principal is $104,000 because this is our first payment. So we didn't pay anything off of that yet. Times our interest rate, which is 5.5. So as a decimal, 0.055. And then this is an annual interest. We just want this for 1 month. So 1/12 of a year. Okay, when I multiply those three to get my product, my interest, rounding to the nearest penny, for the first payment is going to be $476.67. $476.67. and 67 cents. So that's the interest. So if that's the interest, how much did I actually pay off? How much of the principal did I pay off on my first payment? Well, you get that by subtracting these two numbers, right? Let me maybe put a little subtraction symbol in between there. What color is going to pop out? If I subtract these two numbers, right, my total payment minus the interest I paid the bank, I'm left with the principal payment. That's the number I really am happy to pay because that pays my loan down, whereas this payment right here is just paying to borrow the money. So if I just paid this payment, I would be in debt for the rest of my life, right? It wouldn't, if I just paid this payment and didn't pay any principal, I'd just spin my wheels and would never finish the payment, pay back the loan. But in this case, I will pay some back because I'm going to subtract this amount minus this amount, which gives me $373.10. So notice I'm only paying that amount. So therefore, my principal balance after one payment, how much of the loan did I pay off? Well, that's going to be my, let me go with another color. That's going to be my original loan amount of $104,000 minus that tiny little bit I just paid. And when you subtract those two, you get $103,626.90. Okay, this is supposed to be a comma, and that's supposed to be a decimal. There we go. Okay? So I guess what I want to try to illustrate, even though this problem is done, what I'd like to kind of illustrate is this is your first payment, right? That's your first payment. And you can see your interest was really high because your interest was based on the full loan amount. But what if this was ... your, like let's say 150th payment. Now remember 180, your loan is gone. Well, on your 150th payment, your interest rate of 5.5% is going to be based on a much, much smaller number, right? You're almost going to have that paid off. Maybe it's like 20,000 or 15,000 by that time. So your interest payment will be very small, which means when you subtract your monthly payment minus your interest payment, that means on your 150th payment, your principal payment's going to be very large, which we always makes us, I'm going to put a little smiley face there. That's a horrible smile. You can tell I never write these smiley faces. Anyways, when your interest rate, when your principal payment is high, that is basically, money going back in your pocket because you're paying off your debt versus paying money to borrow the money. Okay? All right, next problem. Let's go to number 5. And when we take a look at number 5, number 5 says that we are going to complete the first 2 months of each amortization schedule for fixed rate mortgage amount of $145,100, interest rate at 7.5%, term 16 years. Okay, so when I saw this, I was a little bummed out. Well, a little bummed out because 16 years is not on our nice little chart, right? You go to our chart, it has 15, it has 20. There's no 16. There's no level of detail there. And 16 for a mortgage is weird. To tell you the truth, the ones you really only see mainly is 15-year and 30-year are the main ones. You can get others, but those are the main breakdown that they use the most. So I saw that, and I thought, well, okay, we're going to have to use the formula. So I go ahead and remember the formula. So remember, this is a formula for regular monthly payments. That's the same one I showed before. So the formula, remember it's R equals, and it's going to be, in this case, this particular problem, the principal is $145,100. That gets multiplied by the interest rate, which is 7.5. Write it as a decimal, 0.075, all divided by 12. Then we divide that by 1 minus 12 over 12 plus our interest rate, raised to the 12 times, and then time, how many years? 16 years. When you simplify this, you end up getting, if you round to the nearest penny, you get $1,299.85. And with that, we can start doing this problem. Now, the thing that bummed me out was that I immediately think about how the student, well, the problems that come up, right? And that with that problem, if you make a mistake with that problem and you get that wrong, then that ripples throughout the whole problem and everything is wrong. So it would have been nice if the book gave us something that was on our chart, like 10 years, 15 years, 20, 30, that kind of thing, right? But it didn't. So then I decided, what the heck? Technology is here, right? It's been here for a long time. Online, if you go online, you can find amortization calculators like all over the place. Some of them get a little bit more complicated because they'll start asking about more detail, in the purchase of a home. But I found one that's very easy, and I'm okay with you guys using them. I would use the chart if the problem had those terms on there, right? The problem had the term of the mortgage on there, 5, 10, 15, 20, 25, 30, 40. But if it's not on there, then I've decided to be okay with you guys using this website or anyone you want. So for number 5, instead of using the formula, if you go to this website right here, I guess it's not secure. Oops. Anyhow, use a different one if you want, but this one is a simple calculator that you just put in. So notice my particulars here. The mortgage is $145,100, 7.5% interest rate for 16 years. You punch those 3 pieces in, 16 years. Don't do it in months because ours are all in years, so use the years. So don't do the months, do it in years. And then 7.5%, and you punch the calculate button, and look how fast that is. I mean, it's really fast. $1,299.85. That sounds familiar. $1,299.85. We get the same answer, except extremely quickly. So, if the details of this loan are not on our chart, go ahead and use the calculator on the internet. All right, so we found out that our first number, so once again, they'd like us to fill out the amortization schedule. This is our first month payment, and then our second month payment, and we got to go all the way down to 16 times 12, 16 years at 12 times a year. Once again, what we just found out was our regular monthly payment. That does not change, so that goes right here. That's going to be $1,299.85. Might as well put that down here because that does not change. Okay, we need the interest. We need the interest charge. So remember, interest is not going to be too rough. All you have to do is take interest equals the principal, and so we have not made any payments yet, so $145,100. Maybe that fraction looks too much like a decimal, so let's just keep it like that. $145,100, and that gets multiplied by the interest rate, which we said was 0.075. That's an annual interest rate. I only want interest for 1 month, so I multiply it by a 12th, or divide by 12, does the same thing. And when I do that, I end up getting the interest for that first month based on the whole total amount that I borrowed was $906.88. $906.88. Now that has to be paid to the lender because I borrowed all this money and that's what they want this month. Well, first of all, you're always going to make the payment right there, but they calculate what's their cut on the first month? A lot. $906.88. The leftover scraps, so if I subtract these two, right, the leftover scraps will be what you can apply to your principal, right? So, so let's go ahead and take this quantity minus the interest paid to the bank, leaves me with $392.97. I'm not happy about that. It's not a lot of money that goes to the principal, because then over here, I look at the balance sheet and I want to see that go down. How much did it just go down by? Not very much. How much did it go down by? Well, we take $145,100 minus the amount we paid to the principal, which was only $392. Even though we did pay a big old check of $1,299.85, this is the amount that goes to the principal. The rest goes to paying the finance charge. So you subtract those two and we end up with a measly 140, well, not measly. This is just the amount is too big. The measly thing is we only just, took out a little bit. We only paid off a little bit. We still owe $144,707.03. So there it is, $144,707.03. So that was month number one. Okay, a month goes by, you do your thing. Oh, here's the payment again. It says it's due on the first of the month or whatever. So you go ahead and cut your check of $1,299.85, which you will be doing the same number the whole way through. Now, the thing that changes that you might not be aware of, that you should be aware of, let's call this interest. Let's call this interest for month number one. Let's go ahead and calculate interest for month number two. It's going to be a little different because instead of having to be charged interest on $145,100, we're being charged interest on a little bit less, right? So the interest is going to be charged on, I guess we'll use red to show that. It's going to be charged on $144,707.03. Not much less, but a little bit less, and it will make a little difference. So the interest rate's still the same, 0.075, and we still only want a month, so multiply by 12 or divide by 12 rather, and we will get that our interest for the second month, do I have my figures here, is $904.42. Not much less, but nonetheless it is less, and this is only the second payment. You could imagine if you fast forward 100 payments, this green number keeps on going down, 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 which means your blue number is going to go up, up, up. Okay, let's figure out the blue. What is the blue? The blue is the principal payment, the amount that actually goes to the principal. So how do we figure that out? We take our monthly payment that's fixed. We subtract out the charge to the bank for borrowing the money, which is going down because the amount of money in the bank is going down. And this time we get to apply $395.43 to the principal. So now we take, to calculate how much do you owe after the second payment. Go like that, just kind of. So we have $144,707.03. We are going to apply a little bit more, but not much more. A little bit better, $395.43. And when we subtract those, we now owe $144,311.60. And there's 2 months of paying off a mortgage, breaking it down to the total monthly payment, which never changes, your interest and principal, which do change, and your balance, which also goes down as you go. Okay. Number 6, complete the first 2 months of an amortization schedule for fixed. Okay. So we're doing the same thing again. And once again, we've got, unfortunately, 17 years, which means it's not going to be on our chart. So we'll go ahead and use an amortization calculator. Let's go up here and take a look. Once again, I got to go back. The details of this loan. The mortgage or the loan amount is $450,000. It's 5.75% annual interest rate for 17 years. So once again, I'm authorizing that you can go to that website or any other amortization calculator that you want. You put in $450,000 for the mortgage amount. Mortgage in term of years, 17 years. Interest rate, 5.75. You're not going to move the decimal here because notice they have a percent symbol. So you do not move the decimal when it's a percent. You leave it as a percent. But when we're using a calculator, we need to change percents to decimals. You click on the calculate button and voila, you get your regular monthly payments of $3,461.80. So that's how quick that is. We come back down here and now we know that our monthly regular payments are going to be $3,461.80. $3,461.80. Make sure I remember that right. $3,461.80. Yeah, okay. So that doesn't change. And now all we have to do is just do that process we just did in the previous problem. Our interest for the first month is just going to be the total amount, because we haven't paid anything yet, $450,000 times the interest rate. Now make sure you move that decimal, 0.0575, because the percent is now written as a decimal. And we want to multiply by 12 or divide by 12. So my interest rate for that first month is, this is number 6, interest rate is, not interest rate, interest that I have to pay is a lot, $2,156.25. So to borrow that money that first month, it was very expensive, $2,156.25. Getting notifications, it looks like. Now, okay, so then now what happens next? I'm getting, sorry, a little distracted by this household. How do we figure out the principal payment or the payment to the principal? Right, you take your regular monthly payments minus what the bank gets, and that leftover goes to your principal. $1,305.55. And then how do you figure out your balance? Your balance is, okay, take a look at your balance. What did you start with? A loan amount. The loan amount started as, trying to figure out how I want to show this. Okay, let's do it right here. The loan amount was $450,000. And I want to subtract out that little bit I get to apply towards my principal, which was $1,305.55. Maybe I should put the decimals in here, but of course you're just probably going to throw this in a calculator. And when you subtract that, you should get $448,760.60. $694.45. Okay, now we go for another round. I'm gonna block that off, and let's go for interest for the second month. Well, the interest is going to be calculated rather, and it looks like I'm not going to be able to fit it in there. Let me try again. So interest is going to be calculated. Interest for the second month is going to be calculated by taking the loan balance, which is, it's no longer $450,000, right? We paid a little bit, so now it's this number right here. It is $448,694.45, and that gets multiplied by the, that was weird. Gets multiplied by the interest rate, and the interest rate is 0.0575, and that gets multiplied by a 12th. Okay, so when we do all that work, multiplying those three factors, we get the interest for the second month is $2,149.99. So once again, how do we get principal payment? We just subtract these amounts. So this regular monthly payment minus the interest, and that gives me $1,311.81. Then we take our balance. We take our balance right there, which is $448,694.45, and we subtract out that little bit that we're applying to it, the principal payment, which happened to be $1,311.81, and when you subtract that, you will get that amount right there, which is $447,382.64. All right, there it is, and definitely made it quicker that we were able to use the amortization calculator. Once again, the big thing hopefully you're starting to see is your interest payment at the very beginning of the loan is pretty obnoxious, and it's also equally obnoxious that you're only paying $1,305 or $1,305 off out of a payment that you see going out of your bank of $3,461. You're only paying $1,300 off on the principal at the beginning. But as you progress from month to month and you get way down here, how many years? 17 years. So, once you get to 180 years, you still have 2 more years to go, 180 months rather, 180 payments. You still have 2 more years to go, but you could imagine this number is still the same. Interest payments, this number, because after 180 payments, your principal balance is going to be much lower. So this number goes down and this number goes up, which is great because you're paying more on your principal. But your monthly payment right here always stays the same. That's with a fixed, okay? And often, when people get this fixed, the problem with the housing crisis is people got loans in amounts that they couldn't possibly sustain over time. They couldn't pay it, or there's a little teaser rate where it wasn't too bad at the beginning, and then it balloons up later, and that's just a nightmare. Usually, especially if you're in a career where you're going to get raises over time, it may be a little tight at the beginning and then gets better, but you never want that ratio to be so out of whack that you cannot live. So essentially, almost all of your earnings go to your house payment. And that wonderful house that you thought was going to be an awesome castle ends up being a massive curse because you just hate it, because every month for 30 years you have to pay this amount that squeezes you so much that you can't go out to dinner and you can't go out on vacations. It's just too much. You know, having payments that are super large that consume a lot of your income, in my opinion, can be doable if you're trying to knock off debt and finish up stuff and clean stuff up for a short period of time. But for 30 years of something that chokes you, that's definitely not worth it at that point. Okay. Anyhow, but getting into a house that you can afford is definitely worth it, because that's a commodity that appreciates and gains value over time. And by the way, if you have a $300,000 house and it gains, let's say 5%, that's $15,000. Well, that's based on the house cost, the house price of $300,000. How much money do you have into that? Well, you may have only paid a down payment of $50,000, $60,000, something like that, 70,000, whatever. So you put 60,000, 70,000 down, but that $300,000 asset, the house, appreciates on that size of the pie, if you want to say it. Not your 75,000 you put down, the total cost, the price of the house, which you don't even own yet, is what you're appreciating on. So that is another awesome feature of homes. It's kind of a way of leveraging, which you don't want to overdo, but it does provide shelter. You get tax benefits, and it makes you put that monthly payment away, which eventually becomes your money. It's principal payment is your money going back in your pocket, which is small at the beginning, but it really is a good way to stability and kind of a cornerstone on building wealth. Number 7, find the monthly mortgage payment, including taxes and insurance. So here we have this situation. Let's see. Yeah, okay. So once again, we need to figure out our R value, right? Our regular monthly payments. And we really, the formula is okay, but like I said, when it's this complicated of a problem that ripples into many other answers, if it's not right, it's a real nightmare in terms of you guys trying to put it in the computer. So that's why, once again, I allowed you to go and use something online or a calculator to do that. This is just one problem, so it's not as bad, really. But look at the beauty of this is that it's a 15-year loan at 9%. Well, that's on our chart. So we're just going to go to our chart. I've got a chart somewhere around here. Here's one right here. And I said, what is it? It's a 15-year term, and it's at 9% right here. And we look, right, we come together and we find that number is 10.14267. So now if we want to find that R value that I was just talking about, well, that R value is just going to be, remember that number I got off the chart, 10.14267 times, now we got to figure out, remember the logic of this. This is the amount of money you'd have to pay back for 15 years at 9% based on $1,000. So if you move the decimal point over 3 places and use that number is what? That number is 50.6. That will be now your regular monthly payments based on $50,600. When we multiply that, we get, rounded to the nearest penny, $513.22. So that's that's what our monthly payment is. Let's go ahead and use that in, I think since I've been using red, let's use red. So monthly payment. Monthly payment is $513.22. They would like us to find your monthly mortgage. Now, this, remember we were talking about this, this monthly payment includes what? It includes principal, so the amount you pay towards your loan to drop your loan value down, plus the interest, the amount you pay to the bank for borrowing the money. That's what this is. That's really the bulk of your payments, but there are other fees that come up, like annual taxes. And on this one, on 50,000, yeah, that's about right, I guess, on 50,000. But annual taxes, something people don't realize, but the more expensive your house is, the bigger annual tax you're going to have. Now, we want to know the monthly payment, so we would have to actually take this and divide by 12 to get how much are you going to have to pay annually for taxes. And when you divide by 12, this number, we'll go ahead and do this one in green, is $46.33. Now that's a little deceiving because a mortgage of $50,600, unless you live in some small little remote place, definitely not in California, you're not going to have a mortgage that small. So you know your annual taxes are going to be much bigger than this. I mean, mine are way bigger than that. But anyhow, so this is taxes, and this is monthly taxes. Okay. Our next piece that we need to look at is annual insurance. And, you know, when you have a mortgage, the bank that owns a lot of your house, I mean, you feel like you own the house. You say it's yours, but really, if you put 20% down on a house, the bank owns 80% of the house. So the bank is kind of like, well, wait a minute. What happens if that house burns down? You lost 20%, but they lost 80%. No. They want insurance. The house burns down. They want their money back. So it's going to cost for this particular loan, the mortgage, the insurance is 24.42. So $24.42. So when we add all that up, we end up getting a monthly payment of $583.97. Now this is when we are adding in, so we've got our mortgage, which is principal and interest. So a mortgage with principal and interest, our taxes, and then our insurance. And that's per month. Okay, so that total is $583.97. Next question. Find the monthly mortgage payment, including taxes and insurance, on a loan of $105,000 at 8.5% for 25 years. Is this something that's on my chart? Yes, it is. I don't need to use anything else other than the chart. So let me clean this chart up so I can find it here. We'll go to red again. So we want 8.5% annual percentage rate for 25 years. So we go down and see where these two intersect. There it is. So now what I'm doing is I'm calculating. Let me see how much space I have on this problem. So what I want to do is I want to calculate. I think I'll put it up here. I've got a little space up here. So my regular monthly payments is going to be based on this 8.05227. That is a mortgage of $1,000 for 8.5% for 25 years. I don't want it on $1,000. I want it on 105,000. So we move the decimal point over. We multiply it by 105. Now it's based on not 1,000 but 105,000. So the R value, round to the nearest penny, is now going to be $805 $45.49. Remember, that is going to be our principal paid back to us, or paid back to reduce the loan, and interest, which is the charge to the bank for just borrowing the money. So both go to the bank, but this pays off our loan. This is just, here's some extra money because you're so nice for letting me borrow the money. So anyhow, that's your regular monthly payment. What are we looking for here? The monthly payment is, so find the monthly mortgage payment including taxes. Okay, so here's the other pieces that we need. I'll go ahead and use green. Including annual taxes, right? So once again, to get our annual tax, I'm going to write tax is going to be 1,206 annually. But if I go ahead and divide that by 12, I can get the monthly taxes. So if I divide by 12, I end up getting 105. So there's my monthly taxes. And what's the other piece we're looking for here? Oh, and annual insurance. Oops, annual insurance. So annual insurance is, what happened? Something erased, didn't it? Because it just says X, looks like an algebra problem. This should say tax. Okay. So annual insurance. So annual insurance is $630, but I want to know monthly. Divide by 12, and if I divide by 12, I get $52.50. So what I need to add up is I need to add up my regular monthly payment, which is principal and interest. So this plus my monthly charge for my taxes, my monthly charge for my insurance, and when I add all that up, I get a monthly payment of $1,002.99. These are dollars. Okay, number 9. Suppose $140,000 is owed on a house. The monthly payment for principal and interest is 8.5% for 30 years. And they're going to tell us is, principal and interest is, they calculate for us, is $1,076.48. How many monthly payments will be made over a 30-year period? Oh, this turns out to be an easy problem because we have 30 years and there's 12 payments per month. So if we just multiply that, right, 12 times 30, we get 360. So we end up getting 360 payments, right? 30 years of paying 12 times a year, 30 times 12. Number 10, suppose that $210,000 is owed on a house. The monthly payment for principal and interest is 8.5% for 30 years, and they calculate it for us again. What are you going to ask for here? Let's see. They calculated that the regular monthly payment for this situation is right here. The total interest charged is the total amount paid minus the amount financed. What is the total interest charged? Well, remember, I got to think about this for a second. So the way I could find the total interest charge, okay, because we've been doing over here is we've been finding out if we want the monthly interest charge, we just multiply the loan amount times the percent, and then if we want the month, we just divide it by 12, and that gives us the interest charge for 1 month. But they want to know the interest charged for what? For all 30 years. That's pretty long. Okay, well, probably the easiest way to do that is to take our regular monthly payments. We know we're going to be paying $1,614.72 per month. How many payments am I going to have? Well, we just found that out on the previous problem, right? Didn't we find out there's 360 payments of that amount? And so then, when you multiply those, you get this big number. This is what you've paid back. This is principal and interest paid back. $581,299.72. and 20 cents. That's the total amount you've paid back. So what was our loan amount in this problem? Oh, I was looking at the wrong one. Yeah, here it is, the loan amount. And let me circle that, I guess, in pink. So this is what we had to pay back after 30 years. This was the loan amount originally, was $210, $210,000. So when you subtract out that bit, that difference of those two gives us the finance, the interest that was charged to us. It's a little obnoxious, actually. When I subtract that out, I end up getting $371,299.20. Ouch. You might say, well, how is that beneficial to borrow only $210,000 and having to pay back $581,000 total, meaning the bank charged us more than what we even borrowed? It still is a good deal because you have this house that appreciates over time. And you look at the Bay Area, that was crazy. That's where I grew up, and I saw my parents buy a house for like 30, I think it was like 37,000 when I was 2, and it's now like 2 million. Now that's the Bay Area, so you can't expect that. But you look at housing prices in Sacramento, and it definitely has gone up a ton as well when you go over that time period. So you get that whole appreciation, you get all that, and you get a place to live, stability, and it's forcing you to save. So that's the amount of money that you have to save. And you also get those tax write-offs of the interest as you go. I would recommend, if you can get down to a 15-year, it would save you a lot. Let's put this answer down first before I forget. The answer is right here. I don't know why I don't really have to fill this out here, but $371,299.20. Okay, the problem's done. I wanted to go a little bit further. This is extra, and the extra is I want to say note. Let's look at the same exact loan, but for 15 years instead. In the same exact loan for 15 years, the interest that you're going to pay is $162,231.55. So, as a 30-year loan, you had to pay back 371,000-ish, but as a 15-year loan, you only had to pay back 162, less than half. Decently less than half of what you would. So in that scenario, you borrowed $210,000 to buy this house, and you had to pay back that plus the interest they charge, $162,000. Still sounds like a lot, but it's certainly much better than that. Now, a 30-year, it stretches it over 30 years, so you got to pay the bank longer for borrowing the money, right? And you pay it back slower, so it costs more money in interest charges. The other piece here is that, of course, your monthly payment is higher when you move to a 15. The monthly payment is higher. That's where I hear some crazy, stupid language from, usually from, well, sometimes mortgage people too, but from the car industry. They're just crazy how they say, hey, I can save you money by going from a longer term to, I go from a short term, like 15 years. You wouldn't do 15 years with a car. Car would be a heap of crap in 15. But anyways, but they'll take a short term and stretch it out longer and say, I'm saving you money because they're looking at the monthly payment is lower. That is the dumbest thing I've ever heard. You're not saving anybody money. You're charging them more money over time. It's just your monthly amount is less, but for a much longer period of time. It makes it more manageable to pay, but you're paying more money over time. So if you ever can get yourself to a 15, that to me is better. It pushes you a little bit more, but it finishes it off quicker. And another thing, and you guys aren't this age, I'm more in the realm of looking at retirement. I mean, not quite yet, but I am. I just turned 51 a couple days ago, and one of my goals is that my house must be paid off before retirement. And I think that's a good goal to have, because you go into retirement owning your own shelter, not having to pay anything else. It's yours. All right, next problem, number 11. Number 11 says, suppose you want to purchase a $325,000 home and you have the required $56,000 down payment saved. Complete the table below for a mortgage option presented by the mortgage broker. Okay. Oh, this is our last problem. Awesome. Okay. So this is sort of like the worksheet right here, and then this is where we're going to put the answers over here, down here. The particulars of this mortgage. Oh, here it is. Yeah. There's a principal. Now the interest rate and the terms is not on our chart. So I authorize, yes, go ahead and get yourself, I don't want you to buy a business calculator. Just go online and find an amortization calculator. And we put in, what is that? 269,000 goes into the mortgage. We want it based on 12 years. There it is, 12 years. Interest rate is 4.275. Remember, this is written in percent, so do not move the decimal. And you click calculate, and just like that, we've got our regular monthly payment. Awesome. So I've been doing that in red, so I'll stick with that. Regular monthly payment is $2,391.25, so $2,391.25. Okay, then the next, total of payments over life of loan. So how many total payments are you going to have? Well, your total number of payments are going to be, you have 12 years of payments, and how many payments do you have a month? 12 months in a year. So when you multiply that, you get 144. So you have 144 total payments. Total interest paid on the loan. So what you can do here, let me get rid of some of this so I can have some space to operate. What you can do is you can multiply these two figures. Oops, let me do this in black. When you multiply these two figures, say what that is, you are paying $2,391.25 144 times, right? That's 144 months. So when you multiply those two, you get the total amount that you're paying back, which covers your original principal plus the interest that the bank charged. So what we're looking for is the total interest paid. So if I take this, the total amount that I paid, interest, principal plus interest, and if I subtract out the, what color do I want? If I subtract out the original amount that I borrowed, which was $269,000. So remember, what is in this red payment? What's in that red payment right there is your principal plus interest, and that's per month. So you multiplied it by 144 months. So this black number right here that I'll circle in red is your principal and interest that's charged for the whole life of the loan, which is 12 years. This orange number that I just wrote down is the amount you borrowed. So if you take the difference of those two numbers, remember what was in here in the red number? Principal and interest for the whole life of the loan. If you take out this number is actually principal. So, and actually they did call it principal up there, which is kind of nice. You take out or subtract out the principal, what do you have left? You have all the interest charged for the life of the loan. And so when I subtract it, I get $75,340. So that's the answer there, $75,340. Now what do I have to answer down here? Okay, payments. Okay, so that was, I guess, a work chart. Now we want to know what's our payment. Our payment is $2,391.25. Total of payments over life of loan. Well, the total amount that I paid over the life of loan was this number right here. Why don't I go ahead and do that in red? Well, that was red was the monthly. So the total, maybe I get another color involved. Geez, right there. So the total over the life of the loan paid was $344,340 was paid over the total payments over the life of the loan. Total interest paid over the life of the loan. Well, we found that. That was this green figure right here. So that was $75,300. Sorry, $75,340. And that's it. So, I've given you some tips and some tools that you can use to go ahead instead of using the chart. If the terms of the loan are not on the chart, you go ahead and just use this amortization calculator to make life a little bit easier. I hope that helped. I hope everybody has the goal of buying a house someday. You definitely want to have a down payment. It helps a lot to have the down payment, take a little bit of pressure off the monthly payments, but also it makes it a little less risky if you have a decent down payment, at least 20% or more, because then the bank has some confidence that you have some skin in the game. And because of that, they'll often not charge you mortgage insurance premiums, which is an extra charge on top of your regular insurance you have to have. So you save the money in that area as well. And also, if you have 20% down or more, you get a better interest rate, which means the bank charges you less for that. Also, another piece you want to remember is you want to really work on your credit, get your credit score nice and high, which gives you the best interest rate you can get. You can increase your credit scores. First of all, if you ever miss a payment or have any kind of lateness, call that credit card company and ask them to clean it up, or ask them to forgive you, or whatever, beg, borrow. I don't know about steal, but anyways, you definitely can talk them into giving you another chance or so. But ultimately, you have to be responsible. If you borrow money and pay it back on a regular basis and have a history of that, your credit scores will go up, 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 up. And when you want to get that big loan, let's forget the car loans, but if you want to get that big loan for a house, you'll get an incredible interest rate, which saves you thousands and thousands of dollars over time. All right, this is Professor Gonzalez, and this is our last topic before the end. So we are done learning anything new. Please go in there and take care of your homework and look at the pre-test and go ahead and complete the test number 4, which is everything that's due. Homework and test number 4 is due on May 11th at 11:59. Take care. I hope everybody is safe.